Okay, now it did. Today we're talking about circles. This is our last bit of new stuff for the test. Check me on this, but I think the homework for this section is due on Thursday because the test is Friday and you want to learn this stuff before you have to do the stuff. There's a couple of them. Okay, circles. So to some extent, this is going to feel a little bit like a left turn because we're talking about something, draw a circle, that is definitely not a function, right? It's not a function, it's not one-to-one, doesn't pass a vertical or a horizontal line test by any means. So like we're pivoting a little bit, right, to talk about a different thing. But that's okay. We're just going to figure out kind of some basics about like how we can describe and talk about circles. We need a little bit of terminology stuff first. Let's think about what a circle is. What's a circle? Okay, shape it outside, so like that. Any other? Well, you know what a circle is, right? Okay, you know what a circle is. The circle is a circle. Terminology stuff to describe a circle. Let's think about how you would draw a good circle. Hey, draw a good circle. Okay, you take a fixed point and do what with it? Okay, rotate it around somehow. That kind of sounds like using a compass, right? I should have brought a compass with me. I've got a dozen of them sitting at my desk, but a compass, everybody's used a compass before. Yeah, okay, so it's got like a hinge, right? And then two little arms. One arm's got a stabby part on it, and the other one's got like a pencil thing. And you fix the stabby point in your paper, right? And you try to hold that really still, and then you set your compass to whatever size circle you want, and then you swing it around and draw the thing. If you don't have a compass with you, you can use something like a piece of string or this charger cord that was sitting in the podium. All right, this worked in the last class. Let's see if I can do it again. No promises, but if I hold this fixed and keep the center from moving, then what should happen is I move this around, is that I should trace out a circle, and this is not that bad. I've done worse. It's hard on a blackboard, but you get a circle, right? Again, there's a point here called the center that is fixed. The center is not exactly part of the circle, right? The circle is the outside stuff, but the center is convenient as a reference. So the center is there, and then the thing that defines the circle itself is the boundary. And the thing about that is that it's all the points in the plane, right? Every single one of them that are the same distance away from the center, right? That's why I took the string and held it still so that I was keeping that distance fixed, right? We call that distance the radius. Distance from the center to the outside. If we know the center, then we know where the circle is. And if we know the radius, then we know how big the circle is. Those two things define a circle uniquely then, right? So those are going to be kind of our main focus. Figuring out what those are, or using those if we already have them, or finding them if we don't. But those two things give us all the information that we need to define a circle. So center and radius are going to be important. Some other just terminology stuff that we might see. What's the diameter?
Distance from side to side.
Double the radius, distance from side to side, distance from side to side passing through the center, right? It has to be through the widest part of the circle. You can go from side to side in a sense down here, but that's a chord. It's not the diameter because it's shorter. The diameter is twice the radius. So that's how those are related. And again, important to remember that the diameter or a diameter has to pass through the center, right? It always goes through the middle of the circle, through the widest part of the circle. Okay, so if I know the radius, then I know the diameter. If I know the diameter, then I know the radius because, you know, one kind of defines the other. Okay, what about the circumference?
Then like another way to say it's the area.
It's not the area, it's the length, it's the perimeter, right? It's how long around the outside. Distance around the circle, so it's like the perimeter. We're not really going to do anything with the circumference. I just felt like I needed a fourth bullet point there mostly, but also I wanted to just kind of mention briefly. You remember how the circumference is defined, how you find it? That's the area, but you're on the right track. Circumference is pi times the diameter, or 2 pi times the radius, because again, diameter is double the radius, right? But the thing I wanted to mention is that this isn't a place where like, oh, pi just happens to show up, like it's some magical number that, you know, just fixes this problem for us or solves it. This is how pi is defined. Pi is the ratio of the center to the diameter. Like by definition, that's why we care about pi. That's why it has a special name and why it shows up in places, because it's that ratio. And you know what pi is, 3.1 whatever, and you probably had a classroom with the like wallpaper border that has a billion digits of it, and the kid in class who wants to show you that he knows the first 100 or whatever. Like it's this infinite non-terminating decimal thing, but it's the ratio of the circumference to the diameter. And fun fact, pi shows up in well, kind of it's in the book of Numbers somewhere. I can never remember where, but they're talking about some kind of like pit to be dug or something. I don't remember exactly, but that's like 10 weird biblical unit of measures across and 30 around the outside. So they're using 3 for pi, which is pretty common in ancient, really, really old stuff, because it's pretty close to 3. Okay, anyway, that's our math history lesson for the day. Now, representing a circle. So again, if we know center and we know radius, then we have everything we need, right? That defines a circle. Uniquely, center tells us where to put it. Radius tells us, okay, how big a circle do I draw? How wide do I make my compass, right? So take a second and sketch this circle, center at 1, 3, and radius 4. How you would do that, given that, again, you probably didn't bring a compass with you and don't want to take off a shoelace. Okay, so how can we do it? How can we get, again, like a reasonably good sketch of this thing? We know the center, so let's start there. 1, 3, right? Yeah, and the radius was 4. So how can I at least get some points on this circle of radius 4 that, are right? Count over 4. I can also, that gives me 2, right? If I go over that way and over that way, I can get 2 more by counting up and down. Okay, so this would be what, 5, 3, -3, 3, 1, 7, 1, -1. And then we just, try to make our circle look kind of circly. That's not bad. Usually I end up drawing a thing that looks like a potato or something, but that's an okay circle. Why is counting over and counting up a good idea here? Why can we do that? The radius is how far out, right? But we're putting, I mean, there's sort of an inherent weirdness that we're putting a circle into a square grid, right? So we've got this square grid, and that's great for like drawing straight lines and stuff, right? You can do the slope stair step up and over thing, right? Where you count and get more points. It's perfect for that, but we're putting a circle in there. That's a little weird, right? And it means that most of these points are going to be messy things that don't have nice, pretty round coordinates. But we can use the way the grid works, right? That's what we're doing when we count straight up and down or straight to the left and right. We're using how the grid works to get some information, to get some points on the thing. Okay? We can go the other direction with that too. So if I tell you, let's actually flip over right here real quick. If I tell you that 2 points, 4, 0 and negative 6, 0 are the endpoints of a diameter for a circle. Diameter all the way across, double the radius, right? And through the middle. So the circle itself looks like this, kind of, right? Yeah, it's pretty good. It's pretty good because I cheated, right? Notability makes it a circle for me. But the circle looks like that. Do we have the information that we need then to find the, like, can we find the center? Can we find the radius from that? Yeah, right? Because those are straight across from each other. Those line up well with the square grid that we have, right? They're on the same horizontal line. They're both on the x-axis. How far apart are those? 10. So the diameter is 10. What's the radius then? 5. Where's the center? Well, 5 over from here and 5 over from here would be negative 1, 0, right? So if they happen to be on the same horizontal line or on the same vertical line where they kind of mesh well with the square grid that we have, then I can figure out what I need just by counting, right? The radius, well, let me start with the diameter is 10. That's how far apart 4 and 6 are. That means the radius is 5. And the center is negative 1, 0. And again, I can figure that out just by counting, right? 5 over from negative 6, 5 over from 4 would be negative 1. Okay, that's great. That's cool. That's a place where, you know, taking these 2 points and starting by, you know, either sketching them out or just thinking really closely about like where those are in relation to each other, that might help us. That might save us some trouble later. What happens though when things aren't quite as friendly as that, and we sort of cut through the middle of this square grid? All right, so plot those points, negative 1, 4, and 3, negative 2. Okay, there they are. Now I want you to draw a straight line between them and, you know, try to make it a reasonably good straight line. You know, use a card or something as a straight edge. Now again, the stuff that we need is the center and the radius. If those are endpoints of a diameter, that means that the circle itself looks like this. It's a diameter. That means it goes all the way across through the thickest part of the circle, so through the center. what we need to know is where the center is, the coordinates, and how long the radius is, so how far from the center to the outside. Well, can we estimate the center? We've got a like good picture now, right? I gave you a grid to work with, so I had a like pre-printed square grid. I drew my lines nice and straight. I was kind of precise about where I put stuff. I have a good picture. Where does the center appear to be? 1, 1. Everybody agree? Me too. Okay. Why is that maybe not all we want to do to figure out where the center is? Well, all the same reasons I just said, right? I might not have a nice, precise square grid to begin with. I might not have been really careful about drawing my points. I might not have used a straight edge to draw it, right? I can't really tell from the picture that it's 1, 1 and not like 0.9 or whatever, right? That's not just close to that. How can we be a little more confident about the center being 1, 1? Okay, we can do that. There's some formulas and things that we could do. We're looking for the point in the middle of 2, so we can use the midpoint formula. Okay, remember the midpoint formula? Shoot, me neither. Okay, so what else could we do? We're on a square grid, right? What can you do on that square grid on the XY plane? How can we move that's easy? And sideways, up and down, left and right. Okay, so let's think about getting from here to here. How would I get from there to there? 2 over and 3 down, right? Or 3 down, 2. Do the stair-steppy slope thing, right? If I go down 3 and over 2, that puts me at 1, 1. Right, we were at 4 for the y value. If I go down 3, that's 3, 2, 1. And at -1 for the x, if I go over 2, that's -1, 0, 1, right? So down 3 and over 2. Now, if that's really the center, then if I do that again, I should end up at the other point, right? Okay, so let's do it again. That's an eraser, not helpful. 1, 2, 3. 1, 2. Oh, cool. That's not the right number. So yeah, I guess it is 1, 1 then, right? Down 3 from 1, so 1, 0, -1, -2, and then over 2 would be 1, 2, 3. Okay, so the center's 1, 1. And I'm not trusting the picture now, right? I mean, I still use the picture, but I could do that part with like a, just a sketch, right? I don't need to like just look at it and see where it looks like the center is. I'm counting. How else could we do that? If I didn't want to draw it at all? What if I just look at one of the coordinates? Like just look at the x values. What's the x value of the point on the left that we started with? -1. What's the x value of the one on the right? What's halfway between -1 and 3? How far apart are they? 1, 2, 3, 4. Half of that would be 1, 2, 1, 2, right? So that's the x coordinate that we need then. I can do the same thing with the y's. How far apart are -2 and 4? 6. So from here to here is 6. That means I go 1, 2, 3, 1, 2, 3, right? And figure out, where you land in the middle. Okay, this is all the same thing as using the midpoint formula, except I don't have to remember that the midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. Because if you don't remember a formula correctly, what do you have? Nothing, right? You got a problem is what you got. If you remember half of a formula, that's, not any better than just not having anything at all, really. What did we do here? we figured out what's halfway between the two x values that we had, right? How do you figure out what's halfway between two numbers? If I tell you that your, I don't know, test 1 was an 80 and test 2 was a 90, how do you figure out what your grade is? You take the average. How do you take an average?
Adding them together and dividing by how many numbers there were.
Right? And how many numbers were there?
2.
You add them together and you divide by 2. Right? That's all. It's just the average. So if you're into formulas and whatever, then that's cool. I'm not. So all this really is the average. So let's run that one more time with these 2 points that we're looking at. If I want to find the center, I'm going to take the midpoint or the average. The average of the x coordinates would be -1 plus 3 divided by 2, which is 2 over 2, which is 1. And the average of the y coordinates, oh, sorry. The average of the y coordinates would be 4 plus -2 divided by 2, which is 2, which is 1. Sorry, 2 over 2. I'm not saying all the things that I'm writing. So the center would be 1, 1. Okay, so now we have a whole bunch of different ways to find the center, right? Just using a picture is probably not the way to go, because then, you know, some of these might be, the center might be 3 halves or something. That's going to be hard to pick out just from a graph. But we can do the count over and down thing, right? From one to the other and just split that in half. Or we can use the midpoint formula, or we can use what the midpoint formula really does, which is just average the coordinates because we want the thing halfway in between. Okay, so we've got the center. What else do we need? The radius. Okay, how do we find the radius? Let me get some stuff out of here. Let's keep. Radius is the distance from the center to the outside of the circle, right?
Yeah.
So this radius or this radius doesn't matter. They're both the same. Let's just pick one to focus on. I want to know that length, that distance. Can we just count it? No. If it's over, like straight left and right or straight up and down, then I can just count it because, again, we're on a square grid. But this isn't 1, right? It's some weird diagonal thing. This isn't, you know, I don't know what any of these are in terms of how long they are. So I can't just count it. The directions that I can count are up and down or left and right. It's not that. So other ideas. Okay. You're saying like the diameter? Okay. Ah, but do we know how long that is? How? Again, they're on a diagonal, so it's kind of going through the middle. So I can't just count the length, right? The lengths that we can just count are over and up. Yeah, or up or down, right? So finding the diameter, the full thing, is really just the same question as finding the radius. So like I can't just get it, you know, without doing anything. There is a distance formula. I assume we also don't remember that one. So like, let's forget about that then, right? Because I don't want to go look it up. It's a whole mess. So let's think about, well, I'll write it down first. This is the distance formula. Which, in my opinion, is yucky. But I'm not going to tell you how to think about things. So if you want to use the distance formula, you go right ahead. Just again, keeping in mind that half a formula is not really any good. Let's see if we can figure out what that's doing though. Now I erased a bunch of stuff that we already used, right? Got rid of a bunch of the noise, but I did keep this. Because we're on a square grid, we can count up, down, left, and right. What do we have then? What is that? A triangle. What kind of triangle? A right triangle. Because though those two legs were straight up and down, straight left and right. So we've got a right triangle. What do you know about right triangles? There's the Pythagorean theorem. What's the Pythagorean theorem? A squared plus B squared equals C squared. I know I'm in the middle of this big, diatribe against memorizing formulas, but this one's kind of different, right? This one you've A, known since you were 12 or something, but B, like, this is the one that if someone's going to put just generic math clip art on something, like, it's going to be the Pythagorean theorem, right? Like, the sum of the squares of the legs gives you the square of the hypotenuse. This is one that hopefully is a little bit less like memorizing or remembering a formula, right? It's a little more straightforward. A and B are the two legs, and C is the hypotenuse, which is the diagonal, right? The one across from the right angle. That's got to be the longest one, so it makes sense that you would add the squares of the other two to get it. We know A and B though, right? We know the two legs. We know how far up or down and how far left or right I need to go to get from one point to the other. One leg is length 3, the other leg is length 2. The thing that we're looking for, the radius, is C, the hypotenuse. So 3 squared plus 2 squared is R squared. 3 squared is 9, 2 squared is 4. So R squared is 13, which means that R is the square root of 13. The square root of 13 is not very pretty, right? It's irrational, it's a mess, it's 3 point something, but seeing that the radius is the square root of 13, now I see like, oh, well, no wonder I couldn't just like count it, right? I'm not going to count things on a picture and come up with the square root of 13 as an answer, right? So cutting through the diagonal, I should kind of expect this to, I mean, sometimes, it is a nice number, whatever it can be anything, but I shouldn't really expect it to, or I shouldn't be surprised anyway when it comes out to be something kind of messy like that. The Pythagorean theorem is where this comes from. If you square the left-hand side of this, D, right, then the square root goes away over there. And then these things, ignore the square root and look at these. X1 minus x2 squared, that's just how long the horizontal leg is. And y1 minus y2 squared, that's just how long the vertical leg is, right? And again, I'm not going to tell you how to think about things. You want to memorize a formula, that's fine. I don't care. I'm going to grade you on being able to do the stuff, right? Not how you do it. Obviously, I think thinking about where it comes from is, better for you, better for your brain, easier to keep up with, but you do you. You guys will go on to pre-cal. Pre-cal is mostly trigonometry. Trigonometry is all about, it's right there in the name, trig, right? All about how triangles relate to circles. So if you do go on to pre-cal, you're going to be doing this kind of thing just about every day. So I would, advise you just go ahead and get into the hang of it. But again, you do you. And as I always like to say, as our old friend Pythagoras would tell us, every triangle is a love triangle when you love triangles. So just think of that when you see a triangle.
Pythagoras also come up with the concept of
Yeah, I mean, Pythagoreans did a bunch of stuff. So not necessarily Pythagoras himself, but yeah, that's a whole like weird story. And for more on that, take history of math in the spring of
I remember
25.
Sagan talking about
Yeah. Yeah, there was this one guy who said they had this whole thing about irrational numbers, and this guy said that the square root of 2 was irrational, meaning you can't write it as a fraction. And they didn't like that, so they took him, they put him in a boat and rowed out into the sea and drowned him, which is
Cool.
pretty extreme for math as things go, in my opinion. But yeah, a lot
It's
of,
an irrational way to
Wow.
handle an
It is
irrational-
a very irrational response to irrational numbers. Thank you for pointing that out. I never actually made that joke before. I like that. I'm gonna keep that one. Okay. So we've got the center, we've got the radius. That means we're good to go then, right? Those are the two things that we need. The way that we write down or represent a circle. This is the what we call the standard form equation for a circle. And let's pause for a second before we get overwhelmed at, new math thing. What this is supposed to do is tell me how X and Y need to relate to give me the circle, right, in a coordinate system. Well, X and Y are going to be some, coordinates of some point that's on the circle. What this says is that X squared plus Y squared equals R squared. Hey, we've seen that before. I'll do different labels, right? What is that? It's the Pythagorean theorem again.
Yep.
There's nothing special about that one triangle I drew. Give me any point on the circle, and I can draw in a little right triangle by doing the slope, up and over thing, right? And the radius for any of those triangles that you draw, the radius is going to be the hypotenuse, which is why it ends up being the thing on the right by itself. So this is just the Pythagorean theorem, only we're writing A and B, the legs, in terms of the X and Y coordinates. And we're calling the hypotenuse the radius because that's what it is, right? Okay. That X squared plus Y squared equals R squared would be a circle whose center is 0, 0 and has radius R. What does that do? This is also not new. That just moves it, right? When you've got a, minus H plus X plus 2, X minus 3, whatever, grouped in with something that's happening to X, right? Ignore all this other stuff. We've seen plenty of stuff like that before. That's going to be whatever the thing was, only this minus H is going to shift it to the left or right. So if it's X plus 1 squared, that's going to shift 1 to the, I said plus 1, right? Plus 1 would shift 1 to the left. Minus 3 would shift 1 to the, or 3 to the right. Yeah. So this is just a left-right shift. Usual way, right? Nothing new about it, just what it usually does. What about this? It's going to be up and down. Yeah, it's just going to shift vertically. There's a little bit of a weird thing here. Everything we've looked at up to this point, for the most part, we're talking functions, right? So we're writing y equals formula with x in it, right? This is not a function. Circle does not pass a vertical line test. X and y are on the same side of the equation here. Because everything's to the same side, how do you move stuff from one side of an equation to the other? You do the opposite, right? You subtract it or whatever. Okay, because everything's on the same side of the equation, that means this works a little bit backwards of what we're used to for vertical stuff. Right, I'm used to like y equals f of x plus 5, and that goes up 5. Well, this is on the same side of the equation, so this is going to work just like this does, meaning, backwards kind of. But all those things do, the minus h, the minus k, all those do is shift the function around, or shift the circle around to give you the center at hk. So take a look at this first example. There's an equation of a circle. What does that x minus 2 do to shift the circle? Moves everything 2 to the right. So the center, if by like default it's at the origin, the center, then the x coordinate would be 2 to the right. This, again, that's going to feel a little bit backwards, but y plus 3, that's going to shift 3, but which way? Down. Yeah. It's going to work the way that x normally does because it's grouped in with the y, which is like not what we're used to, right? So that means that the center would be 2, -3. Another way you can think about that if you want, if that feels, weird or unnatural to you or whatever, the x coordinate would be the thing that would zero that term out. Right, so it's the opposite if you want. Like if I plug 2 into that, 2 minus 2 is 0. So that whole term drops out, right? And same thing for the y. Remember, the center is not on the circle. So if you plug this into this, you're not going to get a thing that is true, right? And you're not going to get a thing that makes sense. But the center would zero both of those terms on the left out. So the center is 2, -3. What's the radius? This is c squared or r squared. So the radius would be the square root of 16, which is 4. So that's a circle with center at 2, -3 and radius 4. How would we write down the equation of the one that we just did here that had center 1, 1 and radius square root of 13? Basically filling in the blanks of a Pythagorean theorem type thing, right? So some kind of x squared term, some kind of y squared term, we're adding those together, and it gives you the square of the hypotenuse, the radius. What goes here? Yep. And with y? And the other side? The square root of 13 squared. So 13. That would be the equation of that circle. Okay. Okay, stuff we need to be able to do. Given the center and the radius, write down the equation. Given the equation, write down the center and the radius. Right, that's what we just did in that one and in number 1 there on the back. If we don't have the center or the radius or either, then we need to be able to go and find them. The way you go and find them is doing some kind of, to get the center, doing some kind of midpoint calculation, maybe, or really taking the average of the coordinates. To get the radius, doing some kind of distance or Pythagorean theorem, draw a triangle type thing to figure out how far apart two things are, right? So look at the exercises here on the back. We did 1, 2 is a similar thing. Here's an equation, tell me the center and radius. 3, here's the center, here's the radius, write down the equation. Those should all be basically automatic, right? So what's the center here in number 2? Actually, I don't want to do that one for you. You do that on your own. You do this. You do this. We just did 2 very much like them. 4, 5, and 6. I'm telling you some information about the circle and then asking you to find the equation. To be able to do that, though, you still need the center and the radius. So look at 4. Find the equation of a circle with center, 5, -1. All right, you got this then. All right, I don't need to do anything to find this because we already have it. That is tangent to the y-axis. Somehow that must tell me enough information to find this, to find the radius. Does everybody know what it means to be tangent to something? Touching it, right? It's the way that a circle interacts with a flat surface or a straight line, right? So it's this one point where this round thing is sitting on the flat surface, right? The one place where they touch. So there, probably you want to start by just kind of sketching that out. Again, it doesn't have to be perfect, but think about where that would have to happen. If the center's over here and it's tangent to the y-axis, well, how does that have to work for the circle centered here to be just brushing up against the y-axis at one point? That'll tell you about the radius. 5, we already talked about. Just write down the equation now. Again, those points are directly across from each other, so we can get the midpoint and the radius by just counting, right? 6, 1, -7. and -3, 5, those are not directly across from each other or directly above or below each other, right? Those are on a diagonal. So you're still gonna need to find the center, and you're gonna need to find the radius. That's gonna be more like the problem that we worked through, together from the front, where I have to actually go and find the center, right? Get the midpoint or get the average. I have to actually go and find the radius by figuring out how far apart they are, right? What that distance is. So do those tonight. Tomorrow we'll pick up with any questions that we have there. Give you a quiz tomorrow, absolute value inequality stuff. So take a look at that. Hopefully it's old hat by now, but we'll do that tomorrow and then start talking about test stuff. Okay. All right. Y'all have a good day. I'll see you tomorrow. Good day. Thank you. You too.